to differentiate our tools. I'm going to start out just talking about what we've learned over the past 9 months and try and relate that to how we're structuring our business. So we are FP complete. By December there should be 10 of us. We were founded last March. I joined in April. I would have joined in March, except that I had other commitments that I had to see through. It was founded by a fellow by the name of Aaron Conterer. He was a Microsoft executive. Being a Microsoft executive, he retired sometime around 2000 after building up the C++ Visual Studio business. And he has been off working on nonprofits and starting little startups, and this is our first attempt at trying to do something a little bit bigger. Our focus is on commercial Haskell, and we'll try and define what we mean by that. And our goal is to have a best-in-class set of tools and a platform for people to operate with, and training, consulting, and support services. Right now, our training and consulting is done through partnerships. So if you are doing training or consulting and you are independent and you want to work with us, we are very, very interested in relationships with more training and consulting partners. And most of our people are employees. We do have a couple of contractors. For instance, Duncan Coots from WellType is also working with us. So what we've discovered, I did some basic counting, getting some help from people like Jason to let me look at some of the logs and such. And I see an exponential growth in terms of the number of people who are joining the community, the number of people who are generating code in GitHub. There's a proportionately large number of Haskell packages in GitHub compared to other languages. It's really amazing. The number of commercial applications is growing exponentially. So we're seeing the language take off, and we're seeing companies in the FP space getting good funding. So TypeSafe just got $14 million, and they are executing on that. So it looks like it's a good market. The reason we think it's taking off is, one, people believe that it's much higher productivity. It's easier to prototype in something like Haskell, at least from my perspective, than it is to prototype in something like C++ or Java. There's a conciseness. I talked to the folks at RWE. They had written a program that took various documents and translated them into a normalized form, and they did that in Haskell with DSLs. And the very first version of that was about 30 lines of C# code before they did Haskell, and when they were done, they had about 1,500 lines of Haskell code. Now, that's not typical, but it shows the perception that people have of productivity. Correctness, we all know about. People talk about code validation. I haven't seen a lot of it being used, but there's potential there. And then there's a lot of focus on parallelism because of the attributes of Haskell, but also there's some really cool people working on some really interesting projects with Cloud Haskell and porting the Haskell compiler to generate code for GPUs and FGPAs and work with multi-cores. So there's a lot of really good stuff going on. I spent time talking to a lot of the early commercial adopters. These are the people who gave presentations at the ICFP and the CUFP over the past, I'd say, 5 years. And we found people in finance, we found people in high-performance computing. There's a couple of groups that are doing it within DARPA to try and build safe crash-proof software and highly reliable software that would survive things like nasty viruses and such. There's a lot of adoption in internet services. I think YESO and Habstack have really been contributing to that. And I was surprised talking to people that they actually have whole companies built on Haskell platforms for the web. And of course, there's a lot of DSLs. I think my favorite one is BlueSpec, who built the hardware specification language in Haskell, and are trying to help people be able to be productive in Haskell so that they can extend and add modules. So what do commercial users want? Well, from my conversations, I found there being two types of commercial Haskell users. There's the people who have really bitten off a large chunk, and some of them are in the room here, some of them were working for Standard Charter. They built their own commercial environments. They make modifications to the compiler in order to do things that it wasn't meant to do originally. They've added various types of libraries. They've invented new ways of doing things. When I first started looking at Haskell, there was the whole pseudo capital playing around with iterates and such. And the people who are not those expansive users want commercial quality tools. They don't want hackage hell. They don't want the fast-changing maintenance cycle that happens in a research environment. They want things to slow down a little bit. They want things like backwards compatibility. They want ABI compatibility and API compatibility. And those are things that commercial developers like to focus on, whereas researchers like to move things along really, really quickly. So we found that new users want common use cases, they want templated code, they want examples, they want ease of use from install to release, and they want really, really good performance compared to what may be out there. So the expectations from us is that we would build a predictable platform for companies that are going down the path who want to build commercial versions. They want to scale up, get a lot of users. They don't want to spend a lot of time doing maintenance. They want a lot more libraries and components. They want to see an ecosystem come into being where people are actually producing libraries that they sell so that they're well maintained. They want development tools, and they want development tools different than what they have today. Most of us program in Emacs. I'm a big Emacs user. Those who don't use Emacs use VI. I spent a lot of time doing Emacs and VI when I was developing C++ code. I never could get used to any of the IDEs. But there are people out there who want to learn Haskell, and they want to learn it fast, and they want the tools to guide them through it rather than sitting down and reading a lot of books and learning slowly because they want to scale. And they want better cross-language support, whatever that means. And we talked a little bit about that, Edward and I, but they want to be able to take advantage of libraries that are out there. I think that one of the areas where people keep asking for interfaces is with use with big data solutions like Hadoop. They want to be able to do map and reduce using Haskell and have it integrate really, really well. So the predictable platform I kind of talked about. I think the main thing that people are hoping for are ABIs so that they don't have to rebuild everything every time there's a new release of the platform. And application binary interfaces. The code runs on backward compatibility. This has been, when I was in the world of C++ and Qt, this was a big issue when Qt 3 was out there. Every time they released a new version, the APIs and the ABIs broke, and they did a whole lot of magic in essentially writing private classes to hide the implementation so that the public classes and the public APIs would not change once they were released, and that made it really easy to update the platform without breaking software that people were using. Predictable platform means that the releases are quality controlled. That means everything is regressed before it is put out there, so that somebody who's running a production system is not going to have it break because of an upgrade. And regression testing makes that possible. For the libraries and components, people want to have a really, really good publicly available repository of software, and they want to be able to use it without worrying about some of the libraries being good and some of the libraries being bad. And if we can't get to that, they at least want to know what libraries are good and what libraries are bad. So we want to work with the community to come up with some way of doing regression testing. I see projects moving along pretty well, but also to come up with multiple release processes so that we could have fast-moving and slower-moving code from Hackage and from the platform. People want an extensive ecosystem, and they want to be able to get components that have real value, and they actually want to pay people for that. So if you come up with a component that runs in Haskell and people and it has a lot of value, people actually want to pay you for that. And we're hoping that there'll be a commercial ecosystem built around the fact that people want that. So development tools and IDEs, there's all the old suspects that people bring up about debugging and profiling. They'd like to see it better integrated. But with the IDE, people want something that teaches them as they use the tool so that they can get more people productive faster. And I'm going to talk a little bit about that towards the end. I've been working a lot on learning services. I put a couple of posts up. We want to try and get the community to have a large set of facilities for learning. That means some of it contributed, some of it paid for. There's a lot of good slide material out there. There's a lot of material that is academically focused. We'd like to see more material that's focused on people who are applying the software. So training on techniques for using Haskell as opposed to interesting ideas that will eventually be useful to the commercial community. We want to see a lot of this community supported because 10 people are not going to be able to produce the kind of capacity that we need in order to have enough learning material to meet this exponential growth that's coming. There's interest in cross-platform support. The biggest one that a lot of attention isn't being paid to is .NET. When you go into companies that are outside of the early adopters that I talked about, they're big .NET shops, and they don't necessarily want to cram Haskell into a .NET way of programming, but they want to be able to interoperate to some degree. Whether it is at the message passing level or at the network communications level, which the RPC or such, they want to have something that will work with the existing processes. There's a lot of interest in better hardware support. If you talk to the traders who have specialized hardware, they're doing everything at a very low level because they're writing software to, you guys are probably doing that to FPGAs and specialized ASICs and such. There's also chip manufacturers who are putting all of these good accelerators inside of their chips, and they're finding that it's very hard for people to take advantage of it. So they put chips out with 30 GPUs and 50 cores, and the users aren't getting the benefit of that, and they're saying, why are we paying all this money for all of this extra hardware? So there's a lot of interest from Intel, from Qualcomm, from ARM to get software that parallelizes really well. Mutable Haskell is a really nice way of dealing with it, but we need interfaces that deal with the LUA and CUDA, CUDA interfaces that exist to talk to these devices. So there's a lot of interest, and that's growing, and we expect to see some projects happening really, really soon. And then better OS support. We should be releasing on all the platforms with the same level of quality. So that's what we've learned from talking to people, okay? And that's the path that we're going down. We can't do all of it at once, so we're focusing on a core set of libraries that are a little bit bigger than what you get with the Haskell platform, and then we're developing an IDE. So who saw the debate on Reddit about the IDEs? And
which one?
Well, my favorite was the one where that was why don't we just use Eclipse, or why don't we just take something that's out there and make it a little bit better. And the issue is that we're not really focused on the people who already code really well in Haskell, okay? Because those people are doing reasonably well. And what we're trying to do is capture or hook ourselves onto the growth curve that's about to happen, that we think is about to happen. And in order to be part of that, we need to make it really, really easy for people who don't use Haskell to use it, and hopefully help people who use Haskell on a daily basis become more productive. So if you look at what we're doing and you say, you guys are on drugs, I don't think that I would ever use anything like that, think about what the market's going to be when the people who are doing C# programming begin to dabble in Haskell and they are looking for their Visual Studio. So the product goals that we have are all of the things I talked about and these development tools, okay? And we decided to, on the development tools, take a different approach. And so we went around and read the comments that people made on those Reddit debates. And inside of there, we found one really, really positive comment that said, you really ought to look at the stuff that Brett Victor has talked about. Yep. And in particular, what Chris Granger has done with this thing called Lighttable. Okay? And Lighttable is a really interesting approach to development because it has these guiding principles. One is that you shouldn't have to look for documentation. You shouldn't have to go into a search and say, I want documentation that tells me about this. The documentation should appear when you need it, and you should be able to disable that once you get really, really good at using the platform. Files are not the best representation of code. Okay, if you can pack a lot of stuff into a file, but really what you're focused on is the functionality. Now, Chris Granger focused like his initial Lighttable on Lisp, which is kind of a nice language to pick because it doesn't have a lot of cruft and data structures and such. Everything's a function, and you can break your code into little snippets of functions, and you can have your view of your program be all of the active snippets that you're working with at that moment. Okay? And you should be able to navigate based on that. So the question is, well, how do we extend that to something like Haskell, which has a lot more structure in terms of how you type things and how you specify data? data editors should be able to be anywhere and show you anything. So besides showing you code snippets, they should be able to show you images. They should be able to allow you to edit text. Anything that you're going to be able to work with in your application should be have an editor for. There's also trying to encourage change by producing immediate results. So if you are in a really productive IDE, when you do something, you see the effects of it immediately. Okay, that really follows this whole movement towards scripting, where people want to dabble and see what happens. An IDE should be able to do that with any environment that you are going to develop code that's going to be going into production. And this is really useful if you don't want to re-implement everything in another language in order to get the performance. You want to pick a language that gives you the performance on day one. And then they have this little key thing. They say you want to be able to shine some light on related bits of code. And what they mean is that you want to be able to figure out the interaction between these pieces that you built. So our IDE for Haskell is based on these concepts. And a project is made up of modules. And modules may have a one-to-one correspondence with files, but you're not going to think in terms of files. You're going to think in terms of the modules that you're producing, which means we need to structure them because they need to have parts that are imported and parts that are exported. And then we're going to have options that we need to play with, for instance, pragmas. And we need to be able to hook that into this whole concept of the application being displayed or edited as a set of code snippets. So we preserve this code snippet concept, and your editor is going to show you these snippets that you're working with, but all of these snippets tie to some module that has the structure and the definitions. Help is context sensitive. Things pop up when you need them. You have immediate feedback. The approach that we're taking is to develop this in HTML5 and JavaScript. In a minute, we'll talk about why. I'm about to tell you what we're doing, though it shouldn't be a surprise to anybody.
Could you explain what immediate feedback you get? What kind of feedback you get?
Well, the feedback that you want is that you type something in and you have some kind of context display that actually tells you what the results of what you just typed in. Or if you tie into another function and you call the first function, that you immediately see what's happening in the second function. So you want it to be somewhat interactive, or at least peer interactive, even if it's not.
Victor has a really beautiful video of this.
Although I never really got it. It's like if you're writing like a higher order function,
Yeah.
it's kind of
Yeah,
like
it gets messy.
Yeah.
what exactly are you visualizing? You know, other than that it type checks.
So there's the ideal, and then there's the reality of when you start writing something big, it becomes less immediate. But you want to be able to know as you're writing the mistakes that you're making and the effect that things have and side effects and such.
Connell has some stuff on visualizing higher order functions.
Oh, yeah.
Too. So like sliders and stuff.
So this is work in progress, and I have to say that we haven't solved all these problems. And you may ask questions that are things that that we're debating about right now. And one of the big debates is what is the immediate review. So the organization, you have projects that are hierarchies of modules. And modules are highly structured, but the code segments are individual snippets, that are tied to these modules.
So with the feedback, are you planning on having good support with holes? That was recently added to GHC Head, and
It's something that we'd like to do, but that's not something that we're far enough along with.
okay.
Okay.
That'd be out in 7.8 land anyways. It's out in 7.7, so.
One of the things that we're trying to do now is just step back and think, okay, so there's been 5 people for about two or 3 months, and there's 10 people, and we will probably get a release out the door in Q1, at least in beta. So there's a lot of stuff that we aren't going to be able to do. So, okay, and we're going to enlist you folks to help us figure out where we go next, and we're going to do that not by asking questions, but by putting something out there and letting you folks play with it and tell us, okay, this is good, but that's not good, and we should be going in a wrong direction. And I'm going to talk about how we're going to do that. Okay, so we have this thing called a module map, and that just is the structure that you put around the module. Yeah.
Oh, just as like a general question. So like, are all these things that you're developing, are they going to be open source, or like, will you guys, like this IDE you're developing, is it free, or do you have to pay FP Complete for it, or you haven't decided?
You'll see at the end of the presentation how we're going to make it available for free, okay? But in terms of the longer term, how we're going to make it available and whether there's going to be a free version or not, we just haven't resolved that yet, okay? Our business model is evolving. We would like to have as much as possible be available in the open source. It really depends on what happens as we go forward, okay? But our goal is to have the ability to use this stuff without paying for it. Okay. So I threw a picture in. I can make these slides available. This is how the editor is structured. The display, this is my interpretation of it, but essentially you have the project, you have information about the active module. So if I start typing in here some code and it requires an import, then the code's going to say, oh, well, you probably want to import this module, and it's going to say, this is available in these 3 different modules. Which one do you want? And you click on the one that you want, and it will appear over here in the active module. So the idea is that you start typing, you start adding things, and the editor tries to predict what you're doing and help you do things without having you do a lot of extra construction. And this isn't a new idea, but it's something that people who are not used to using Haskell will find very, very, very helpful. That anything that's been defined someplace in a library will be put in a database, and that database will be activated as you type. So the example that I give is, let's say I wanted to create a module that's called count entries, and it's going to have a function that's called list directory, and in list directory I define it as having a particular type, and I then say list directories equal, it's going to know that I'm currying, it will auto complete the list directories. As I fill in the information, I might say filter no dots. We'll know that no dots is a Boolean, that it takes whatever my type is, in this case file path, to a Boolean. It's going to suggest that. It's going to say, oh, well, I found that in control.monad, so do you want me to add that? And you'll click on it and it will add it to the module. So the idea is that as you do things, things flow. Okay? It tries to be smart. A lot of the time the people are writing code, they're browsing. So as you browse, as you mouse, the editor is going to pop things up. It's going to tell you, for instance, if you hover over something, what the type is. If you move someplace else, it'll tell you what module something might be found in. Mouse over will give you information. clicking will display context associated with that, and double clicking will open up an editor that allows you to change it. So that's the structure that we're using. So where's this leading? So why did we start with a web GUI and develop our IDE there? The first version of this is going to be available as an online version. So one of the things we spent a lot of time on is developing a multi-tenant hosting infrastructure. We're going to offer this in its first release available under limited resources, because we're actually paying Amazon for the use of the underlying infrastructure. But this is going to be available online. It will be running from a web interface. The accounts will be free. And then we'll have a commercial download version for people who need to take this from behind the firewall, so that they can interconnect with the facilities that are available within their company. So questions on that?
That makes sense.
So the idea here is you folks will help us. The newcomers will come and they will see that Haskell is not a difficult thing to learn, even though the world out there thinks that it's a foreign, scary approach to programming. It actually is a very graceful language to use, and with the right help, people will be able to be productive really quickly. So, questions?
If you want to make a good bad dichotomy in the Haskell language verse, are you looking at extending package, or introducing this new bit of metadata to package, or having a alternative repository packages to package?
We don't look at ourselves as competing with package. So anything that we do that is improving the quality, we want to push back to the community. Okay, so we want to be consumers of package. And we want to get our software from package, and we want to see the overall quality of package improve. We would love to get to the day where we don't have to do anything. That we just consume it, package it up, and we're off working on the next thing. Okay, so we're not interested in competing with the open source community. We're here to leverage it. Other questions?
So another group of people you might want to look at for inspiration is the Racket guys.
Yeah.
Yes.
Because they've sort of been working on their IDE for decades.
Forever.
And it's really impressive, a lot of the stuff they do in there. And they're still, like, generating ideas. Like, there was a RacketCon not that long ago, and there was a guy there talking about, like, having color-coordinated error messages that, like, have the error message, like, 3 different colors in the error message, and then, like, the source code is highlighted in those colors to show you where the error message corresponds to, and stuff like that. So
Bartosz is following that, and he says, God, we should be doing that.
Yeah.
We should be doing that.
yeah, they have a lot of cool stuff.
Speaking of Racket, another one of their concepts is to have different languages within the Racket system, many of which are sort of student versions of Racket. So they export objects. That's one of the things that is different error messages. Notice that a lot of people will type X++,
So you've opened up the door to a whole bunch of discussions we're having, and one of the discussions is, what do we do about error messages? Okay, and how are we going to make the error messages better immediately and then over time? Okay, and how do you change the error messages to fit multiple communities? So we're thinking about that particular problem of what are we going to say to the guy who sits down in front of this the very first time, and the only thing that they have is a copy of, Learn Me a Haskell or the Hutton book or something.
So to that point, there's actually been a lot of work that has been done in the Haskell community. If you go back 10 years, there was Martin Salzman did a bunch of work on constraint handling rules, and one of the things that came out of like the work on Chameleon and some of the stuff that was done there was they had there was Helium, which was an early like wannabe Haskell, like I guess you could say.
Yep.
It was like a learner's Haskell,
Yep.
which was designed to give very nice error messages and whatnot. There was also some work done. I think it was one of the constraint handling rules projects. I can't remember the author, but they went off and they put all sorts of really careful error messages annotating the functions for most of the standard library, so that you could say when you tried to map something incorrectly or do something wrong there. There was a lot of really useful diagnostic stuff there. And then finally, there's this type error slicing research that's been going on. I can give you some pointers on that.
Yeah, I think
All of those are.
I think we, as I've talked to people about this, people have sent lots of pointers. So
Okay.
Send me the pointer just in case I don't have it.
Okay.
But I've been getting there's something someone's just sent me in the last month or so that was something that sounds like that. But
Okay, yeah. The type error slicing is the stuff I'm most hopeful for in this
Okay.
particular regard, personally.
But the yeah, go ahead.
Are you planning to use the new feature in GHC 7.6, I think, introduced where compilation could complete inserting runtime errors, time errors?
Dynamic errors. I don't think that we're working with that right now, but that's something that's on the list. Okay. We've been building from a 7.4 base, so we just started going to 7.6, and so we're a little bit behind that. I did want to say that one of the things that we get a lot of requests for are specialized interpreters for various environments. So the quant guys have been saying, well, gee, we want something that looks like, using Python, NumPy, SciPy, and we'd like to see somebody do something. So we're entertaining things like that for the future, so that you might have, a statistical interpreter or a quantitative calculation.
There's actually a project out there. OpenBrain has a thing called Bayesive they've been working on, which is a Haskell-like language. It's got like a embedded FRP like front end, but it's for doing Bayesian and stochastic calculations.
Yeah, I saw that when I was doing the search. So that's how I connected with Carter.
Okay.
I was trying to find someone who was thinking about this, and Carter said, "Oh, I have this whole idea of something like that." So,
Yeah. I think they've gotten farther than Carter.
Yeah. But boy, that would be really nice, a nice add-on if we could make that part of the ecosystem, if we could do it with Haskell.
Yeah, I'll talk to you later about
Okay.
stuff around that.
So, any other questions about what we're doing? Does it sound like we're doing something useful?
It's interesting.
This is for people that are learning to use this, right?
We are going to start with that, but there are lots of people who would like to see something like this available really quickly.
So I'm just learning, and this sounds like the greatest thing ever.
Well, that's our goal. So our site is going to have three parts to it. It's going to have the IDE, it's going to have a learning center, and then it's going to have a place to interact with other people that are using our platform. So The Learning Center is really, our Learning Center is really tutorials with the IDE embedded in the tutorial. It's kind of a really cool thing.
You know, one thing you could do, when the user types function signature, you could search your collection of other user snippets and show them a piece of code that somebody else wrote.
Within a single company, maybe.
It's CloudGen.
You know, if you talk to Bartosz, that's his dream.
Mhm.
Okay, Bartosz's dream is that someday in the future you write very little code. You just start putting things in, and and the thing pops up and says, "Yeah, we got a snippet for that."
Well, that's what, you just use Gin or whatever
That's
right
right.
now in LambdaBot for a lot of those, as long as you stay sufficiently parametric.
But you have to run it, don't you?
Oh yeah, you type Gin, whatever, but you could
But Gin
turn
is-
around, you could
is-
tie that, you
you
could
could
tie that
just-
into your
yeah, right,
REPL
you could
very
just- you
easily,
could just
or
tie
your
it.
into your GUI.
Gin is writing logic.
Yeah.
Logic.
But what we would like it to be is that some of those snippets that pop up would be tied to components that people have to buy.
Are you sure you want that part recorded?
Well, there's nothing wrong with,
No.
there's nothing wrong with a little bit of capitalism.
Sure.
Yeah.
Did you say that you were going to have all your learning materials be integrated with IDE?
We are going to try and encourage the community to develop learning materials that will tie into our IDE. Okay, so when I talked about the Community Learning Center, there's 3 parts to it. One part is stuff that people just give you. The second is people work on it and they do the speaker notes and they structure it so that it follows a format, and then it actually all the examples are links to our online IDE, so that you can actually just integrate that into your course. So if you want to teach Haskell, we're going to encourage you to use our platform. But also there's a format that we will have that will be an XML format, and hopefully we'll have an editor for it someday. But it will allow you to immediately integrate your whole tutorial that you write in this format with our IDE. So that if you were going to write something, you can give it or you can sell it.
Is that format finalized yet, or is it sort of a chicken and egg problem?
We're going to have something out fairly soon. Okay, and it will be version .0 point something.
Oh, yeah, so you do it, maybe you'll have to update it.
Yeah, well, but that will be our problem.
Right. Well, I've been trying to turn over a new leaf and actually write some documentation for my library, so it might be a good goad for me to experiment.
So
one
I'm
step
in the
further.
process of writing. I wrote a blog about wanting to build this community driven learning site, and so my next post, which is taking a little bit longer, is trying to structure how we're going to fit this language and the format of the slides and the other types of materials that we want people to contribute and how we're going to curate and such. So I have the next installment coming.
I'm curious, is there like lots and lots of beautiful stuff in academic papers, like in the pearls and things like that, functional pearls? How much would, say, if I picked up a functional pearl, how much would I have to adapt it to get it to be the kind of level that you want to?
It's probably going to be work. Okay, it's probably going to be work because a functional Perl is going to be something that that you probably have to understand the academic paper in order to this dates me, but Grok. I think people still
Yeah.
Boy, we would sure like to figure out a way to encourage people to do that. So it might be that if it's a really, really good Perl, that we pay you, and if it's a little Perl and you give it, we might have a program where we'll give you an iPod, or so we're going to try and come up with really creative ways of encouraging people to do this.
Okay.
All right. So I've taken a lot of time, I'm sorry about that.
That's okay.
But it's been really fun talking to you guys, and I'm looking forward to getting all the.
Yeah, the links,
that you're
yes.
gonna send.
Remind me if I don't remember to send them.
Okay,
I'm
so
gonna-
thank you
I'm
very
gonna-
much. Yeah.
Thank you.